students, welcome back to Sir Rasayan. In this lecture I am going to explain about hyperconjugation. And also I will explain how to use this concept of hyperconjugation for solving problems. Now electronic displacement in covalent bonds lead to a number of effects like inductive effect, resonance effect, hyperconjugative effect and electromeric effect. We have studied about inductive effect and resonance effect in our previous videos. Now see, hyper means excessive or extended. So hyperconjugation means excessive or extended conjugation involving sigma bonds. In resonance we have studied about pi or pi p type of orbital overlap. But in hyperconjugation there is sigma pi or sigma p type of orbital overlap. This p orbital may be incomplete or may be vacant. Mainly in three types of system we can observe hyperconjugation. In three types of system. What are those systems? Number 1, in this system there is one pi bond and here there is one CH sigma bond. So pi bond and CH sigma bond should be in alternate position. So in alkene of such type there is pi bond and CH sigma bond are at alternate position. So what will happen? Now see, with respect to this double bonded carbon, this carbon is alpha and the hydrogen attached with this carbon is called alpha hydrogen. So here three alpha hydrogens are there. So hyperconjugation is possible. If there is only one alpha hydrogen with respect to this double bond, hyperconjugation is possible. So what you have to do, you just break this bond. This sigma bond will shift electron density here. Like resonance you have to give this double-headed arrow. So next structure is this one. This pi electron density is shifted here on this carbon. So here it is CH2, 2 electrons, so negative charge, and here there is one H plus. In a similar way, for this hydrogen and this hydrogen, similar structure we can write. So you maintain this one and this hydrogen as it is. Here there will be H plus, double bond CH, this one. Third hyperconjugative structure, how we can write? We can use this one, this CH bond. So here these two keep as it is. Here there will be H plus, double bond CH, CH to this. So 3 alpha hydrogens means 3 hyperconjugative structure. So we can write number of alpha hydrogen is proportional to number of hyperconjugative structure. Remember this one, this is very important. Another point you have to remember that when we are writing this structure, there is no bond between this H and this carbon, between this H and this carbon, between H and this carbon. So Another name of hyperconjugation is no bond resonance. If free radical and CH sigma bond are at alternate position, then also hyperconjugation is possible. So this is also alpha carbon, and the hydrogen attached to the alpha carbon are called alpha hydrogens. So these are alpha hydrogens. And remember, this carbon is sp3 hybridized. Okay. So here, since it is free radical, we have to show homolytic cleavage. So we can show like this way. Hyperconjugative structure means and here it is H dot. So here there is incomplete p orbital. So here 3 alpha hydrogens means 3 hyperconjugative structures are possible. So this free radical is stabilized by hyperconjugation. Remember, like resonating structures, each hyperconjugative structure is hypothetical. Now see, with respect to carbocation, this is alpha carbon and these hydrogens are alpha hydrogens. So with respect to the carbocation, if alpha hydrogen is there, then also hyperconjugation is possible. This bond will supply electron density here. We will get this hyperconjugative structure. Similarly, involving this hydrogen atom, we will get this one, and involving this hydrogen atom, we will get this hyperconjugative structure. This effect was first noted by Baker and Nathan. So it is called Baker-Nathan effect. Now we will solve some problems. Number 1, hyperconjugation involves delocalization of 4 statements are given. We have to select the correct one. Number 1, pi electrons of carbon-carbon bond. This is not correct. Electrons of CH sigma bond of an alkyl group directly attached to an atom of unsaturated system. So we have seen already, for this type of system hyperconjugation is possible. So this is correct. Electrons of CH sigma bond of alkyl group directly attached to the carbon having free radical. We have seen for this system CH3 CH2 dot hyperconjugation is possible. So this is correct. Lone pair of electrons. This is not correct. Next question is, arrange the following according to increasing stability. All these are carbocation. This is methyl carbocation, this is ethyl carbocation, this is isopropyl carbocation, this is tertiary butyl carbocation. So you can see this is 1 degree means primary, this is 2 degree means secondary, and this is 3 degree. Since it is attached, this carbon is attached with 3 carbon atoms, so this is tertiary or 3 degree. This carbon is attached with 2 carbon atoms, this is secondary, and this carbon is attached with only 1 carbon atom, so it is primary. So what's the stability? So here number of alpha hydrogens you have to see. Here no alpha hydrogen. Here this is alpha carbon, with alpha carbon 3 hydrogens are there, so 3 alpha hydrogens are there. Here these and these are alpha carbon, this and this. Here only this one. So total 6 alpha hydrogens are present, and here this is alpha carbon with respect to this carbocation, this is also alpha carbon, and this is also alpha carbon. So 9 alpha hydrogens are possible. Now see, by inductive effect you can consider its stability order. Here only 1 plus I effect group is there, here 2, here 3. But that's why this is more stable, because charge neutralization here is more, or you can say dispersion of charge is more, positive charge. This is next, stability order, this is next, then this is. So most stable is this one, then stability will decrease in this direction by inductive effect. But hyperconjugative effect is more important than inductive effect. So here 9 alpha hydrogens means 9 hyperconjugative structure. Number of hyperconjugative structures. Here since no alpha hydrogen, so no hyperconjugative structure. Here 3, here 6 alpha hydrogens are there, so 6 hyperconjugative structures, and here 9 hyperconjugative structures since 9 alpha hydrogens are there. So stability order is this one. So it is increasing in this direction. By inductive effect also you can give the same answer, but this is more accurate because hyperconjugation is more important than inductive effect. In the same way, you can say the stability order of methyl free radical, ethyl free radical, isopropyl free radical, and T-butyl or tertiary butyl free radicals. Here number of hyperconjugative structures are 9, here 6, here 3, and here no. So obviously stability will increase in this direction. Now arrange the following according to increasing stability. Alkenes are given. With respect to this double bond, there is no alpha hydrogen. This is ethene molecule. So here no alpha hydrogens. Okay. Here this is propene. With respect to this double bonded carbon, this is alpha carbon, and here 3 alpha hydrogens are present. Here with respect to this double bonded carbon, 3 and here 3. Total 6 alpha hydrogens are there. This is butene. In 2-methyl butene, there is, with respect to this double bond, this is alpha carbon, this is alpha carbon, this is alpha carbon. So total 9 alpha hydrogens are there. And here with respect to this double bonded carbon, total 4 alpha carbons are there. So total 12 alpha hydrogens are there. So the more the number of alpha hydrogen, the more will be the number of hyperconjugative structure, more will be the stability of the species. So this is most stable, then this one, after that it is decreasing in this direction. So this is increasing order of stability. Next question, hyperconjugation is most useful for stabilizing which of the following carbocations? 4 options are given: neopentyl, isopropyl, tertiary butyl, methyl carbocation. So you should know the structure of all carbocations. Then only you can understand whether there is alpha hydrogen with respect to carbocation or not. If there is alpha hydrogen, hyperconjugation is possible. And the species where most number of alpha hydrogens are there, that is the most stable one. Now see, this is neopentyl carbocation. With respect to this carbocation, this is alpha carbon. So with this carbon, 3 CH3 groups are attached, no hydrogen is there. So there is no alpha hydrogen. Therefore, no hyperconjugation. Here, with respect to this carbocation, this is alpha carbon, this is also alpha carbon. So 6 alpha hydrogens. 6 alpha hydrogens. Here with respect to this carbocation, 3 alpha carbon atoms are there. This is alpha carbon, this is alpha carbon, this is alpha carbon. So altogether 9 alpha hydrogens are there. And for methyl carbocation, no alpha hydrogen. Therefore, where maximum number of hyperconjugative structures are possible, for tertiary butyl carbocation. So that is most stable one. So hyperconjugation is most useful for stabilizing which of the carbocation? This one, tertiary butyl carbocation. Now see, we have seen the stability order of carbocations due to hyperconjugation is this one. Tertiary is the most stable, then secondary, then primary, then methyl. Now this is with this carbon, positively charged carbon, 3 carbon atoms are attached. So this is tertiary. Here also with this positively charged carbon, 3 carbon atoms are attached. This is also tertiary. So how to compare the stability order between these two? Now see, with respect to this positive charge, this is alpha carbon. So these hydrogens are alpha hydrogen. This is also alpha carbon. This is also alpha carbon. With respect to this carbocation, this is alpha carbon, this is alpha carbon, this is alpha carbon. So here number of alpha hydrogens, here how many? 3, 6, 8, total 8. And here 3, 4, 5, 6, 7. So here number of hyperconjugative structure is more for this species than for this. Obviously this is more stable than this one. Next, between CH3 CH2 plus and CD3 CH2 plus, which carbocation is more stable? This is with this carbon, positively charged carbon, one carbon atom is attached. This is positively charged carbon, one carbon atom is attached. So this is primary, this is also primary. But here see, 3 alpha hydrogens are there, and here at alpha position 3 deuterium atoms are there. If mass is more, bond strength is more. Remember this thing, if mass is more, bond strength is more. So between CD and CH bond, which bond is more stronger? Bond strength. Bond strength. This is more stronger bond than CH bond. CH bond is weaker than CD bond. So CH bond cleavage is much more easier than CD bond cleavage. So here hyperconjugation is more than this one. So between this and this species, which one is more stable? This. Because you see here for CD3, you have to clip this bond. So that is difficult than this CH bond. Now see, between these two alkene, which one is more stable? This is disubstituted because with double bonded carbon, 2 methyl groups are there, and here also with double bonded carbon, 2 methyl groups are there. So both are disubstituted. So how to compare the stability? When you will draw the hyperconjugative structure using this methyl, what you will do? You will break this bond. Then this CH will supply electron density here. But when you will draw the hyperconjugative structure using this methyl group, how you will draw? You will break this bond, and then this CH bond will break and it will supply electron density like this. So both are opposing. This is called cross conjugation. So here, to write the hyperconjugative structure, you can see there is cross conjugation. But here, when you will draw the hyperconjugative structure, we can show this carbon like this way. Here CH3, how we will show? We can break this bond, it will supply electron density in this direction, or we can break this bond, it will supply electron density. So this is called unidirectional conjugation. From left to right, we are showing the arrows. This is unidirectional conjugation. And whatever I told, for to write the hyperconjugative structure, here from left to right we are showing arrow, and to draw the another structure we are showing the arrow from right to left. This is called cross conjugation. So which one is more important? Unidirectional conjugation is more important. This one is more important. So obviously, which one is more stable? 2 is more stable than 1. Stability order. So in this video till this, thank you for watching.